Hi everyone, so I make that just after 9 AM UK time, so we're going to make a start. So first of all, thank you for joining our webinar today. This is our final session in our three-part Raytec Live Drop-in series. Some of you may have attended our previous two sessions. I hope you found these interesting and informative. If you didn't manage to catch them, then don't worry, you can access the recordings on our website at www.raytecled.com. So today we're going to be comparing Wellglass lighting and bay lighting. There are two of us on the webinar today. So my name is Charlotte Loudon and I'm the Digital Marketing Executive here at Raytec. And I'll be joined by Dave Coulthard, our European Business Development Manager. Dave will be running you through the main content of the webinar, so I'll pass you over to him shortly. But first, we have a couple of housekeeping rules. The presentation should last around 20 minutes, and then following this, you'll have a chance to ask any questions you may have. Just submit your questions in the questions tab in your control panel, and you will come to them at the end. Other than that, I think we're ready to start, so I'll pass you over to Dave.
Good morning. Thank you for that, Charlotte. So good morning to everyone, and thanks for taking the time out of your busy day to join us. Hopefully you'll find today's session worthwhile. So I was going to introduce myself, but Charlotte's already introduced me. I'm Dave Coulthard. I'm the European Business Development Manager at Raytec, and I have the pleasure in taking you through today's webinar and hopefully answering any questions you have at the end. So let's make a start. So as is customary, let's start with looking at the agenda of the topics we are going to cover in today's webinar. Firstly, we'll try to define the generic terms of Wellglass and bay. Then we'll look at how the design of a luminaire affects the light output, how it reflects on the maintenance of the luminaire. And finally, we'll go on to look at other important features. Firstly, we want to understand some of the main differences between a Wellglass luminaire and an LED bay luminaire. So let's make a start with the Wellglass luminaire. A Wellglass is a traditional design of luminaire. I'm sure many of you guys have come across them in the past and still see them on many sites today. And it's based around conventional older lighting technology, typically HID or high intensity discharge lamps or high pressure sodium. The whole luminaire design is based around housing this more traditional type of technology and the way they emit multi-directional light. More recently, as Wellglass fittings have evolved, some manufacturers have started to retrofit LEDs into these traditional housings, and we'll look at this in a little more detail later in the webinar. In contrast now, the LED bay luminaire is a more modern type of fitting, and they tend to be designed specifically around the LEDs, so bespoke manufacturing, rather than the LEDs just being retrofitted. Of course, there are different designs of these luminaires, and different manufacturers will take different approaches. But during this presentation, we'll concentrate on the Raytec bay luminaire. So hopefully now have a basic understanding of the main differences between the two types of luminaires. The next area we will look at today is how the different designs affect the way they emit light, and importantly, the quality of their lumen output. To try and highlight these differences, we'll start by doing a quick comparison between the two types. Because the Wellglass was originally designed around conventional technology, which throws out light in all directions, it's constructed to allow light to be emitted at 360 degrees. But because LEDs are a directional light source, this causes a few issues when you try to fit LEDs inside a Wellglass, but we'll come on to this shortly. For an LED bay luminaire though, this means it's easier to direct light where it's needed. And in the case of a Spartan bay, we use individual optics over the LEDs to collimate and direct light where it's needed most. In contrast, because of its design to allow 360-degree illumination, with a Wellglass luminaire, it's very difficult to target light where it's needed. So for a Wellglass using conventional lighting technology, such as a HID lamp, they tend to use reflectors to try and target the light. But this isn't particularly precise and is very inefficient, meaning a lot of light can be lost. In contrast, an LED bay luminaire should be available in a variety of different beam angles. So the Spartan Bay, for example, is available in 30, 60, and 90-degree angles, and this is achieved by using lenses. Typically, lenses are rotationally symmetrical, which give a nice round light distribution. And the 30, 60, 90 patterns were chosen to mirror the traditional technology lighting patterns of narrow, medium, and wide beam angle. So this slide is to demonstrate with images what I tried to show with words on the previous one. So the Wellglass luminaire is throwing out light in many directions. And probably looking at this slide again, I think there's one arrow missing, which would be an arrow pointing upwards to the base of the fitting, where light will also be directed and inevitably lost. Heat will also be directed there. So if you can imagine this fitting is ceiling mounted at 30 or 40 feet high, you'll see light supplied at high levels on the walls and even ceilings rather than directed towards the task of footfall areas where it's needed. In comparison, the LED bay luminaire is throwing the light straight down, but with the option to use different beam angles to throw the light into wider areas if required. Now we've mentioned that we use optics to direct the light to achieve the different beam angles, but as a slight aside, I thought it was also worth pointing out that not all optics are equal. So what do I mean by that? Well, in my former role, working for Raytec as a supply chain manager for over a decade, I know firsthand that it's extremely important to get the correct optic to match the specific LED you are using in every product. So for example, many LED chip manufacturers use a similar package size. Let's say, for example, a 30-30 form factor or 3 milli square. Most optic manufacturers will make one range of optics to fit any 3 milli square LED. This is common sense. It allows their products to have the broadest market appeal. So this 3 milli I mentioned is actually the outer package size of the LED, its footprint, if you will. But the internal light emitting points can vary. They can vary in height, so higher or lower towards the base, physical size, and output angle. And each of these variances has a not insignificant effect on how well the optic couples and collimates the light. So the idea is to provide both an efficient and even distribution pattern. And at Raytec, we do this through intensive research and lengthy testing through the design and development stage. So I've had a little digress. I'll try to get back onto the main topic now. We want to look more closely at those Wellglass luminaires which have been retrofitted with LEDs. So for me, this creates somewhat of a hybrid style luminaire, creating an LED Wellglass product. So I'd like to take a couple of minutes to discuss some of the limitations of this approach. Because Wellglass luminaires don't have the same footprint as a more modern bay luminaire, they tend to be restricted by using either cob LEDs, either one large powerful cob LED, or they may even use 4 or 5 slightly smaller cob LEDs, but cluster them together. This has various drawbacks, but before we cover these, it's probably worth me trying to explain what a cob LED is. So there are two main types of LEDs used by manufacturers in most lighting applications today. By far the most common is an SMD or surface mounted device. These are still the most popular on the market. This LED chip is externally fused to a printed circuit board or a PCB and is especially popular because of its versatility. It's resistant to vibration, heat, temperature. So if you look at an SMD LED closely, you'll see a small point right in the center. Even if you look at one on the back of your mobile phone, there'll be a tiny little black dot in the middle, and that's the actual LED chip. Now that chip in white light is protected with phosphor powder, which looks yellow or orange. The yellow ones tend to emit more of a daylight, so 6,000-ish Kelvin, and the orange ones generally emits a warm light, so 2,700 to 4,000 Kelvin. But the second type that we've mentioned is a COB LED, which stands for chip on board and refers to the mounting of a bare LED chip in direct contact with a substrate, typically a silicon carbide or a sapphire. This produces LED arrays but dispenses with the need for a PCB layer. They tend to have a minimum of 9 individual smaller LEDs within the chip, but can have many more than this depending on the size and form. So hopefully that's given you a little bit of a better understanding of what a COB LED is. So let's try to get back to the topic in hand. What are the potential drawbacks of using a chip-on-board LED? Firstly, it makes the luminaire very difficult to keep cool. To put it in practical terms, it's effectively like putting all the individual LEDs used in an LED bay luminaire, which would typically be 24 to 48 LEDs in a high bay, and packing them all into one component. And again, coming back to the footprint of the luminaire, a Wellglass can't possibly offer the same levels of thermal management as an LED bay. The majority of LED bays will have large fins and extrusion on the back, designed to carry the heat away from the LEDs. And as we've covered many times in our webinars, keeping the LEDs as cool as possible is absolutely paramount to extending lifespan, extending performance, and keeping reliability of the LEDs. If they are not thermally managed, you can slash the actual system life of the unit. Secondly, it is much more difficult to control the direction of light. As we discussed in a previous slide, an LED bay can use individual optics over the LEDs to focus and direct the light where it's needed. This is much harder to do when using a large chip-on-board LED, as you have multiple light sources to try to direct efficiently. And I remember many years ago talking to some technical guys at Raytec, and we were testing chip-on-board LEDs, and one of them used the example, trying to direct this light is like trying to herd cats. So I think that's a pretty good analogy. And furthermore, packing all this power into a single component is likely to cause issues with glare. And finally, while it wouldn't have been an issue with conventional technology, LEDs simply aren't designed to go inside this kind of large dome glass cover. So the actual glass on a Wellglass unit tends to be 10 or 12 milli thick, and it's toughened and annealed. It needs to be able to withstand the 200 or 300 psi typically required. This thick toughened glass is likely to cause striations or rings of light and dark on the floor, where the light undergoes total internal reflection of the inside of the glass. You can also expect to typically lose 15 to 20% light output just through this thickness of glass. So there's been a lot of information on that slide, but I guess my key message that I'm trying to get across here is the fact that Wellglass luminaires are designed for conventional technology and not LEDs. So when you do put LEDs inside a Wellglass luminaire, there's a whole host of potential problems associated with it. Now, we're going to move on to ease and frequency of maintenance between the two designs. We've talked about the large protruding glass dome, which is a feature of the Wellglass. We touched earlier on the thickness of the glass and the ability of it to contain pressure, but this is designed with internal pressures in mind. Remember, EXD is designed to contain any risk of explosion. But this still leaves a large glass protrusion that is particularly vulnerable to being smashed as a result of impact. And as we know, hazardous area applications often tend to be high risk, where there is a real chance of an impact occurring. So to try and combat this, manufacturers do tend to offer protective wire guards with these types of luminaires. Now this can help, but it isn't always effective. If the impact is big enough or targeted enough, it could still smash the glass. And if the glass is smashed or chipped or cracked, then it tends to be very difficult and expensive to replace. Generally, it will be encapsulated into a machined casting, which includes a flame path, and it will be held in place by often what's referred to by manufacturers as a cement. But this is more typically some form of epoxy compound. Oh, skipped on a little bit there. So to replace this, the glass and body must be purchased as a complete assembly to maintain its certification, which can be as expensive as purchasing a new unit. Another potential weakness is that the cement is open to the elements. So this cement is prone to wither away and crack over time with external temperature fluctuations and general weather, again requiring replacement. While a bay luminaire will likely use a glass cover, the glass tends to be flat, like it is on our Spartan High Bay, you can see there, and therefore inherently stronger than the dome glass on a well glass. Furthermore, because it's flat and not protruding outside the luminaire, it means it is less vulnerable to being hit or smashed. And to give you an example, because of this, we can get away with using a 5 mm thick toughened glass on a high power bay. And in the event that you do need to replace the glass, if you have a modular EXE designed luminaire, like the Spartan high power bay, it means the glass can be removed and replaced on site relatively quickly and at significantly less cost than the well glass. Another important thing to consider is how the luminaire has been certified. Wellglass luminaires tend to be EXD certified, and as we covered in our first webinar, EXE versus EXD, an EXE luminaire is much easier to maintain. Now, because I covered this in the first webinar, I don't want to go through this again in great detail. The recording of this is available on our website if you weren't able to attend, but I will give you a very quick summary. So EXD luminaires are designed using flame paths and therefore require a high number of bolts to be undone in order to access internal components, as well as these flame paths requiring periodic maintenance, checking, and potential regreasing. So this makes maintenance much more complex. So we're getting near the end now, slightly over the 20 minutes, but before we come to the end of the webinar, I want to do a quick summary of what we've discussed. It's also worth pointing out that LED bay luminaire may offer a number of other features through its design, which can be of great benefit to an end user. An example of that, which I want to show you now, is the remote PSU feature of the luminaire. So the luminaire actually allows a PSU module to be detached from the main body and is a feature of the modular design we try to instill throughout the Spartan product range. The PSU can then be mounted remotely from the main body at ground level, so it's easy to access if any maintenance needs to be carried out. The main luminaire can be mounted where needed, up to 100 meters away from the PSU module. This kind of feature is often ideal for applications where bay luminaires are commonly installed, such as warehouses or grain storage areas. So to summarize some of the key benefits of a modern LED bay fitting versus a pendant fitting, LED bay luminaires provide higher quality light output. The light output is directed where you need it and not wasted in areas you don't. So what does that mean in practical terms? Well, if you look at a lighting design and you plugged in two comparable lumen output units, one Wellglass, one LED bay, the lux levels in the required areas would almost certainly be higher on the bay fitting. An LED bay fitting will also be less vulnerable to damage and much easier to maintain as they don't have flame paths, as well as offering more features and greater flexibility. So I guess my takeaway message would be that above all, you should always try to select a luminaire which has been designed around the LEDs. Only that way will you get the best performance, the best reliability, and the best features. So thank you everyone for listening. And now we will take some questions. Unfortunately, this does mean that I have to switch my webcam on. So you have to see me. So apologies for that, but we'll do that now.
Hi everyone.
Hello.
Right, brilliant. So we're going to take some questions. We've had a few come in. So we've got one from Michael. So Michael asks, what is the difference between Wellglass and pendant lighting? Dave, you mind taking that?
Yep.
Taking away with that one?
So we will, for that one, a Wellglass in reality is a type of pendant fitting. So because a Wellglass gives light 360 degrees on horizontal, it can only really be mounted horizontally. And the definition of a pendant light is that it's suspended and mounted. So most Wellglasses are also pendant fittings. And a typical pendant fitting will be suspended by a chain or threaded bar at a central fixing point. So I guess that would be my answer to that one.
Brilliant. So Carrie has asked, am I right in thinking LED bays cannot then be EXD certified?
LED bays cannot be EXD certified. No, LED bays can be EXD certified. It's just a different protection method. So you can have an EXD bay or an EXE bay. Just the ones that Raytec produce and manufacture, they're EXE, they're designed to be more modular, they're designed around the LEDs. There's no reason you can't have an EXD fitting. Provided, I'll temper that, provided it meets the site specifications. So provided it's a zone 1 fitting or it's a class 2B or whatever the specific requirements are for the site, provided it meets that, the protection method it uses to meet that is okay.
Okay, that's brilliant. So David's asked, does the remote power supply mounting alter the HAZ area certification?
Ooh, that's a good question. Not as far as I'm aware. So what we find a lot of the time with the remote mounting is that they may want to mount fittings in an ATEX area, say zone 1 or zone 2, but they may want to have access to the control gear in a safer area, in a safe zone. So they'll mount it up to 100 meters away, which then gives them access to the control gear if required. But I will double check that and come back.
Okay, brilliant. So we've got one from Ben. So Ben asks, what are the rough limits and differences of using a low bay and high bay fitting?
Okay, that's a good question. So we tend to refer to our fittings as bay fittings. So we try to move away from the traditional low bay and high bay. A traditional low bay would be mounted at maybe 5 or 6 meters plus, and they were typically a 70 watt or 150 watt sun lamp. Now, they would give out anywhere from 4,000 to 7,000 lumens. So what you find now in the market is that most LED linear fittings give out 5,000 to 7,000 lumens. So they tend to replace some of the low bay products within the marketplace. Now, the traditional high bay would, I would say, be up to maybe 15 meters high is where you would pitch the high bay product. And again, depending on the height, it depends on the lumen output, but I would say that the overlap there is in the middle, maybe 8-9 meters. You want to be looking at a high bay product.
Okay, brilliant. So Graham asks, are the fixtures DALI 2 enabled?
So
I'm assuming he means our fixture.
it does, yeah.
Yeah.
So I know that the high power flood is DALI enabled. I don't know if it's DALI 2 enabled, so I don't want to give an answer on that yet. Can I check and feedback?
Yeah.
But they are certainly
We'll go
DALI
back.
enabled, so they are, daylight adjustable, controlled.
That's fine. And the last question that's in, so Alan's asked, why do manufacturers still use EXD and Wellglass fittings? And he's also asked, and why do they put LEDs inside if they are not fit for purpose?
Oh, that's a loaded question. So I can't 100% agree with the question, because it's not that they're not fit for purpose, they're just not as fit for purpose as an LED product would be. They have a lot of limitations. But as a supply chain manager, I can sort of take a step back and think why a manufacturer would do that rather than designing a bespoke luminaire. And I would say, firstly, the ease of development and certification. So if you already have a product certified that has a bulb in, say, for example, and you want to upgrade it to LEDs, then to use the same housing, the same drivers, the same gaskets, the same everything, and simply put LEDs in, it's much easier to get that product through certification. Secondly, with that would come the cost. So for an EXD product, it's typically, I'm guessing here, £50,000 or less to bring it to market because of the cost of the casting tooling. They're not that expensive. However, if you look at a bespoke LED luminaire, so not an EXD product, you would be north of £250,000, £500,000 in tooling and investment to bring it to market, which is a big outlay, and it would also take longer. And one thing I come across sort of day to day is that there's been a big push in the market over the last 5 years where I think the message is across that LEDs now are better than traditional lighting in most applications. But there's still a little bit of lack of awareness of the difference between a good LED product and a bad LED product. And so if you put LEDs inside of an EXD Wellglass product, you look at data sheet, it says it's an LED product. Some people will think, well, that's just as good as any other LED product, when in reality, it does come with its limitations.
Right, brilliant. So I think that might be all the questions. Let me just double check. Yeah, so I think that might be everything. So we're going to wait around a few more minutes just in case anybody else has any questions. However, I think you've probably seen enough of our faces, so we'll turn our webcams off. But before we do that, I just want to say a huge thank you to everyone who's joined us today and for our 2 previous sessions. I hope you found them interesting. If you have any further questions, don't hesitate to get in contact with us. And also just to say again that the recordings will be on our website under the resources section. Well, the other 2 are on there, but we'll put this one up after, and we'll also send you the link. So yeah, that's everything from us. So we'll turn our webcams off now. Yeah, and I hope you all found it interesting. Thank you.
Thank you.
Bye.